Okay, once again with the definite integrals, let's see if we can handle this last one. Those last two have been not too bad, so you feel like there might be some kind of trap coming up, and indeed there is. Here's our function, y equals x plus 1, and they ask us to evaluate it from negative 3 to 5. So negative 1, negative 2, negative 3 is like here. So there's our negative 3. And then we have 0, 1, 2, 3, 4, 5 is like this. So this is fine to do a definite integral over something like this. We'll get a numerical answer and it won't be a problem. What you have to be careful about is that if you're trying to find the area here and here, this integral will not give it to you, and we'll see why in a bit. Let's do the integral first and get our number, because we know that part and it's not all that hard. The antiderivative of x plus 1 is 1 half x squared plus x. I'll leave out the c's. And we have to evaluate it at 5 and at negative 3. So if we do that, we get 1 half of 5 squared plus 5 minus, and now we do the same stuff with negative 3. Half of negative 3 squared is 4.5, and then we get plus negative 3. So 12 and a half plus 5 is 17 and a half, minus 4 and a half minus 3 is 1 and a half. 17 and a half minus 1 and a half is 16 is our total. But now let's do some plain old geometry and see what we get here. If this is a triangle and it is 2 units wide and down to here is 2 units high, then its area should be 1 half base times height. There should be 2 units worth of area in this left-hand triangle. In this triangle, which goes from negative 1 to 5, that gives us a base of 6. This height is 5 plus 1, 6. So the area for this rectangle should be 1 half base times height equals 36 divided by 2, 18. The total area here should be 20, but that's not what the indefinite integral is telling us. Do you see why? Why is this integral not quite the same as finding the area between that line and the curve? It has to do with the sign and the concept of what we call signed area. Normally when we're talking about area, when we're talking about painting walls and laying sod and things like that, we think of area as something that has to have a positive value, but that's not what happens when you do an integral. In the integral's head, so to speak, if integrals could think, it would be considering all of this to be negative area because it has negative height. And so this came out to be a total area of negative 2. This section, where all the heights were positive, came out to have a positive area plus 18. And the integral combined those and said negative 2 plus 18 gives a total of 16. This is the total signed area. Maybe not what you were expecting if you were thinking, hey, I need to find the areas of these two triangles, I'll just use an integral. So you have to be careful with this. If you're graphing something, you want to think about, is it always negative? Is it always positive? Or is it some mixture of the two? This one was a mixture, and that means you can get some unexpected answers out of it. If you wanted to do the total area, if this was something you were painting and you expected to get positive numbers all the time, the way that you would handle it is to do one integral from negative 3 to negative 1. That's this part. And then another integral from negative 1 up to 5. That's the second triangle. And then force them all to be positive by putting absolute values around them. In other words, if one of them has a negative sign, just chop it off. If you do this, you can do integrals one piece at a time and say, this piece is going to be negative, I'll force it to go positive. This piece is going to be positive, so it's going to be all right all by itself. And if you do that, then you would get positive 2, positive 18, and a total of 20. So we can try to catch you with this in test questions by saying, find the area, find this shaded area, and then give you an equation, and then just sit back and see if you're careless about setting up your integral. Please always do the sketch. See if your function is always negative, like in one of our previous examples, or always positive, like in another one of our examples, or if it's a mixture like this. If it's a mixture like this, you can save it, but it takes a little extra work.